All right, let's talk about number 3. So number 3, my strategy of let's get everything in terms of sine and cosine, we already have that. So we're going to have to look at something else. So once again, I'm going to deal with only one side. So I'm going to start with the left side. And I notice that there is a sine of x in both of those terms. So just like you had, let's say 5 plus 5y, where you factored out a 5, we're going to do the same thing. We have a greatest common factor that we can pull out. So we've got the sine of x, and then we need to figure out what's going to go in that parentheses. You have to have a 1, because if I distribute, I would get the sine of x, and then minus the cosine squared of x. Well, then I remember back to, okay, I really need to know this Pythagorean identity because I use it all the time. So I don't see a sine squared x plus cosine squared of x, but I do see 1 minus the cosine squared of x. So if I were to subtract the cosine squared of x, where you're just manipulating your equation, I would have the sine squared of x is 1 minus the cosine squared of x. Well, notice right here I have a 1 minus the cosine squared of x. So I'm going to substitute a sine squared x in its place. I have to also bring down this sine of x that I factored out. And so just like x times x to the second is x to the third, when you have the sine of x times the sine squared, you're going to get sine cubed of x. So I've only been dealing with the left side. Now I notice the right side is exactly the same. So I have verified that identity.